All right, guys, in this video, I am going to show you how to test for leaks and more so how to set the pressure on your which starts with a leak test. You can see that I've been spraying my Dawn solution everywhere, and let me show you what happens when you get a leak. You'll start to see movement and it will blow bubbles. So this is just a strong Dawn detergent. I'm gonna mix up some more, but you can clearly see where you see that bubble being formed at. Well, that's a leak, and that seems to be between this 1/2-inch flare connection and this adapter. So I need to, before I go any further with my testing, I want to take care of the leaks. So let me get a couple of wrenches, which I have already out near my bag, and let's tighten this connection up so that it's not leaking. All right, so I dried all the old soap off. I've tightened this with my wrenches. I've refilled my bottle with more water and more soap. I like to use just regular Dawn, a heavy mixture, heavy on the soap, and it's cheap, and you're not worried about using too much of it. Spray it liberally, and let's take a look. Do we have any bubbles forming? Just look on the back. All right, looks like we're good now, guys. Just a little. And see, the soap mixture is so strong that it's gonna blow that bubble if the leak is there. All right, so now that we have verified that our system is leak-free, we can go ahead and start our test, which this would normally include a low pressure drop test. So it's very important that you test that your equipment isn't leaking. And I'm doing that utilizing a plug. This would normally go to the rest of the system for the RV, but I have it plugged off. So I know that my side is good. I can disconnect this, hook it into the system. You can do this while it's in line. It's still gonna show you the same results. But today, since I'm not testing a system, I'm only setting this regulator up. I can cap it off and do it that way. So let me get my manometer hooked up. Let's sit you guys right here. Let's get this. And I've ordered yet another manometer, another digital manometer, and I want to see how it compares to the Klein, because I feel that the Klein isn't as accurate as I would have it to be. Now I have the gas pressure on. Okay, so this is a brand new regulator right out of the box. It's failing. You know, anything over 14 is a fail. That's the lockup pressure. It's too high. So don't go throwing it away just yet. These things don't come set from the factory. You may get some that are within range, and that's nice, but you still have to check. Now we're gonna get a flathead screwdriver. Now you see why I keep a flathead in the bag. And we're going to start adjusting it. I'm turning clockwise and it's going up, so I know to go counterclockwise to turn that back. I need to turn the gas on to a 50% load. Now I know I need to go counterclockwise. All right. So now with my 50% load, I want to get this down to 11 inches of water column. Okay. She's humming. She's not happy. Like I said, this regulator is kind of sketchy the way it came. So let me show you something here. So I have set that to 11 inches of water column, and so when the gas is on, it's right at 11 inches of water column. That's the only way you could set it. And then you shut it off. The lockup pressure is not supposed to exceed 14, but it is. That would be a fail. So we got the Klein out, and let's go ahead and zero it. It has us on P1, which is this one. It's actually in the mail. So I've zeroed the Klein. I'm using P1, and it's saying 13.7. So according to the Klein, this is in spec. So there's a good example of why you also have to use your equipment. So now I'm gonna set it with the Klein to 11 inches of water column. I don't like the way the Klein's jumping around. I mean, is it 10 or is it 11? See, that's what I don't like about this. Yeah, that's why I don't like this Klein. This thing is unreliable. Let's go over to P2. Let's move it over to P2 and see what we get. That's the negative pressure side, but I'm going to use it if I can get the hose on. Let me do this, guys. That's fine if it locks up at that, as long as I also have 11 on the 10.94, 10.93, 10.73, 10.85, 10.87. Let's adjust this. I want a nice 11. Okay, 11.4, lock up, 14.28. See, this is bad regulator. Two different machines, even though they're given different numbers, which I always said that this cheap one was more accurate than this expensive one. And I have a third one coming, so we'll be able to calibrate it with a brand new one. And I'll just do I might have ordered a water manometer, which is the most accurate and what we calibrate these off of, and I can just make a water manometer just using some hose and a ruler and a piece of wood, make a slack tube. But yeah, now it's settled down to 13.78, which would be in range. So for me, it's good. I can keep it for testing purposes, because I definitely I wouldn't put this in anybody's unit, because my testing is just using the gas to turn on a furnace, water heater or something, and it has enough pressure to do that. So gotcha. All right, guys, and it has settled down to 13.5 on the lockup, and it just changes too much. It never really stabilizes. That's what I don't like about this. That's what I don't like about this manometer.